Alrighty, so in our last video we talked about like the finishes, and we talked about these thresholds and how this dot symbolizes an aluminum threshold. That's significant because aluminum is used at all the vestibule areas and all the cooler areas. So basically areas where there's a difference between hot and cold. And the reason being is that, like, if you were to use a marble one here, the different things, the change in temperature so quickly causes material to shrink and expand, and it causes problems, and it can crack and it can break and just be damaged very quickly, which is why aluminum is used, because it dissipates heat quickly, and it's very versatile in that way, and it's just a good material for that specific purpose. And you can see it sits right here on the exterior on this top of this foundation wall, and it acts as a transition between those two spaces. So if we were going to go to the details of how that would be built, we would go right here, AE 515, and you can see these aluminum transitions. You can see that right here. This is the cooler door. So inherently, like, this would be the inside of the cooler. This is the concrete foundation wall. Here's the slab on the outside, and then this space is called an expansion joint. If we come right here to the wonderful internet, you can see they put an expansion joint because if they don't, when concrete butts up against itself, it'll expand in the cold or whatever, and it'll crack each other, and it's not a good deal. So they put the joint in there to prevent that, and that's what the whole point is between the inside space and the outside space, is to keep them separate and keep the inside protected. So they have this threshold, which is good for that. And this would obviously be all insulated because it's a cooler room and keep it safe. Right here is the vestibule area. On the inside is the vestibule, and the door. This is just a hollow metal door frame. It sits on here and kind of just acts like that. Pretty simple. It's pretty simple construction. If we come over here, though, it gets a little bit more complicated. So this is a tile detail. So if we were to go back, actually let's first look at what the tile looks like. So I used to work at a restaurant, and it was basically exactly like this detail. So we had this tile floor. It was non-slip, and they would slope downwards, just as this did. So that when, like, food or something land on the ground, we could spray it away or just go into a drain. So like this would slope down, and eventually it into like a drain over here, and you just go down through the pipe system. If not, it would like leak and could permeate, which wouldn't be a good deal. So looking at this, you can see so on the ground, you have your just your insulation material. So underneath the concrete slab right here is an insulation material, just to protect the concrete from the outside. And you can see that this just sits on top of that, and the concrete right here is actually what's sloping downwards, and everything just slopes with it. And you can see right here, this is what's called the cleavage membrane. This is right here. When you don't have a cleavage membrane, your tiles are more subject to become loose, to become unstable, and to fall off or break. Like I said, I worked at a restaurant, and that's exactly what happened. They didn't have a cleavage membrane. It was just sitting right on top of the mortar, and because of that, it just broke off, and it wasn't good. So it's important to have that, and that would look like it's kind of just like it kind of just looks like that. It just sits on top of that, and it's pliable, and it can bend and stuff, so which allows the concrete more leeway. If you look right here, this is another expansion joint, just because that expansion and contraction effect. It just allows that space to go through, like if water gets through. It just has extra space, like for weathering and such. Then between the ceramic tile and that bed is a bond coating, which bonds it to the surface, which is going back to the internet. This is just this stuff right here. it just bonds it. Bed is 3/4 to 1 1/4 inch dip, so there's a 1/2 inch like give between there. And the tile just sits on top of that. The grout goes in between there, and then we get up to this wall, and this is where it kind of gets interesting. So if we come back here, where was it? Right here. So you can see that the tile is going up the wall, but it has several layers to keep the tile bonded to the wall. So whatever material it is, in our case, this is insulation, but it serves our purpose. So you have your waterproofing. Then you have this wire metal lathe. It's kind of just like a thing that the grout and mortar sticks to. So there's like the mortar bed, and then that sticks to this grout layer, and the grout sticks to the tile. And then tiles have texture on the back that grip onto that, and that's kind of just how that system works. But yeah, that's pretty much those two details. They're pretty simple. When I work construction, I did this oftentimes, and it's important that you do, because like I said, I worked at that restaurant, and if things are installed improperly, the restaurant starts to fall apart, or in this case the STC, it's important that like the labs and the cooler rooms for testing stay at consistent temperature. So yeah.